This is section 6.2, exponents and multiplication. Our objective today is to multiply powers with the same base. So let's look at what happens when we multiply numbers with exponents. We're going to expand each of these in order to multiply. So a to the fourth power is a times a times a times a. Times a to the third power is a times a times a. So what would this make if we combined it? Well, 1, 2, 3, 4, 5, 6, 7 a's is a to the seventh power. Let's look at the b's. B to the sixth, so b times b times b times b times b times b times b squared, which is b times b. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8 b's. It says b to the eighth power. Do you notice anything about this? Let's look at the anatomy of an exponent quick. This big number at the bottom, it'll be normal sized. That is the base. We call that the base. And then the little number that's up to the top is the exponents. It's very important to know those words because we will be using them. So multiplying powers with the same base. To multiply numbers or variables with the same base, so that same big number, we add the exponents. So 3 squared times 3 to the 7th, we add those exponents, 2 plus 7, and we get 3 to the 9th power. Notice that this base has to be the same and that it does not change. So let's practice writing with a single exponent. We've got the same base, so negative 2 times negative 2, so our base is going to be negative 2. Notice that it's given in parentheses, so my answer has parentheses. I add my exponents. 3 plus 5 makes 8. There's my answer, negative 2 to the 8th power. Try these three. Write them using a single exponent. All right, for this first one, we have a base of 6, exponents of 2 and 3. I add those and get 5, 6 to the 5th power. For b, my base is negative 4. Notice that I don't have a power here, so it is a 1. 1 plus 7 makes 8. Remember, if there's no power, it is an invisible 1. So for letter C, it's got a 3 as its base. I've got a 1, a 2, and a 3, which makes it 3 to the 6th power. All right, we are going to write an expression for the area of this rectangle. Remember that area of a rectangle is base or length times width or base times height, whichever way you want to say it. So we have x squared times x. Well, remember that's x to the 1. So our base is x. We add those exponents and we get x to the 3rd. Try this one. A square has a side length of n cubed. Find the area of the square. Remember that a square has all sides the same, so that's n cubed also. All right, we should have taken n cubed times n cubed. My base is n. 3 plus 3 makes us 6, so my area is n to the 6th power. So quick refresher, what is the commutative property? Commutative property says that a times b equals b times a. Basically, I can switch the order of any multiplication problem or addition problem. We're going to be looking at multiplication today, though. We're going to simplify this expression. Negative 3x to the 2nd times 5x to the 4th. We can break apart the different multiplication pieces. So we have negative 3 times x to the 2nd times 5 times x to the 4th. And now the commutative property says that I can rearrange this however I want. So we're going to put the negative 3 and the 5 together. And then we're going to put the x squared and the x to the 4th together. Well, negative 3 times 5 is negative 15. X squared times x to the 4th, our base is x. We add those exponents and get a 6. So our answer is negative 15, x to the 6th power. We're going to try these ones just like those last ones. Try them on your own. All right, for the first one, we multiply the 2 and the 3 to get a 6. Take our a, we have an a squared and an a to the 1st, so we get 6a to the 3rd. The second one is just a straightforward one. Our base is x. We add those exponents to get a 13, so x to the 13th power. Negative 4 times negative 3 is positive 12. Y to the 5th times y to the 5th is y to the 10th, so we get 12y to the 10th. Here's your assignment.